What is up, Math Maniacs? Section 1.62, Solve Linear Inequalities with your boy, Mr. B. Here we go. Any inequalities. So they look like this and they look like this. They're talking about less than symbol is here and the greater than symbol is here. And when you get to go and graph them, they're graphed with an open dot. Now, less than or equal to is this, and greater than or equal to is this. So when you graph them with a closed dot, like this. If you want to graph all the numbers that are less than or equal to -1, let's say x is less than or equal to -1, we're talking about -2, -3, -4, all those numbers, it looks like this. And so you put a closed dot but then here you can see x is greater than 2. You put an open dot to signify that we're talking about all the numbers that are just greater than 2, like 2.1, 2.2, 2.5, 2.9, and 3, and 4, and 5, and 6, all the numbers that are shaded right here. So that's how you graph these individually. Fun fact, you can combine them together into what's called a compound inequality, where you're graphing two kind of thoughts at the same time. So what if you were to graph all the numbers between -1 and 2? It would be written as an inequality like this, and on a graph here all the numbers in between -1 and 2, not including -1 and not including 2. So that's like numbers like 0, 1, 1.9, 1.9999, 1.999999999. That is a number that is less than 2, and it satisfies this inequality, and it's graphed right here. Here's some other. What if you wanted to graph these two ideas at the same time? All the numbers that are less than or equal to -2 or greater than 1. Here's less than or equal to -2. You can see it's going in this direction. By the way, if you ever see the variable first, variable, and then symbol, and then number, and you forget which way to shade what direction, the arrow right here, the symbol and the arrow are going to be the same. So x is less than or equal to -2, same z's going on right here. The dot is on -2. Remember that it's a closed dot because we want to also include -2 in this shading. So when you shade this in, it's -2 and -3 and -4 and -5 and -10 and -100 and -1,000,000, and all the numbers that keep on going in that direction. Also, to satisfy the second half, it's all the numbers that are greater than 1. Notice this is just a greater than symbol, so that it's an open dot here on the 1, and then shading all the numbers to the right. See, symbol, arrow, same z's going on. This is basically shading in all the numbers on the entire number line except the ones in between right here. They're kind of like, you can point you can go like this for this one, touching thumbs. And then what we have here is you can have, instead of touching your thumbs, you can point your thumbs away, spreading out in either directions, that way and that way. All right, let's take a look at this other one. Here, one more thing we have to know is that anytime you multiply or divide by a negative number, you have to switch the inequality's direction. So if you have -2x is less than -4, and you want to multiply both sides or divide both sides by -2, then all of a sudden it looks like this. You divide both sides by -2, and this -4 divided by -2 is +2, and the symbol gets flipped. So you can see, put an open dot on the 2 and shade it in this direction. Everything else is that you see when you're solving normal linear equations is also going to apply here. So here we have to undo the addition subtraction first to subtract 20 from both sides, and then divide both sides by 2, and you get this. Here, in this compound inequality, check this out, there's 3 different parts. There's a left side and a right side, but here there's a left side, a center, and a right side. So what you do to one side or one part, you have to do to all the others as well. So it looks like this. I'm looking at this center part, and I want to undo -10. I do that by adding 10 to all 3 parts. When I add it to -4, I get 6. When I add it here, I get cancellation. When I add it to the right-hand side, 14 plus 10 is 24. Wow, then I got to undo the multiply by 6. Do that by dividing all 3 parts by 6. So we get 1, x, and 4. And what that looks like on the graph is this. An open dot here on the 1, and we're shading everything in between the other dot, and then the other dot's on the 4, closed dot over here. This is how we symbolize all the numbers that are going to be solutions to the original. Let's do it again up here. I see variables on both sides, so first thing I'm going to do is subtract 5x from both sides. And I get cancellation here, and 7x minus 2x, minus 5x is 2x. Undo the subtract by 4, undo the multiply by 2, and we get that. This would be tricky to graph because it's 3 is greater than x, and actually, and so I think what I'm going to do is I'm going to go ahead and write it this way because it's just a bit more familiar. X is less than 3 is much easier to graph. You can see the graph would be going off in that direction. All right, so next, just wanted to throw it out there that I've got 3 kids. How many? Not 1, not 2, but 3. And they're pretty awesome. How many siblings do you have? Why don't you tell me when you come back into the class? And maybe you know some of my kids. They're not too much young at the time of this recording. They're not too much younger than y'all. So let's jump over here to solving this inequality. We've got, I'm seeing this statement, I'm seeing this statement. They're connected with the word or. So I think what I'm going to do is just solve them individually. I'm going to subtract 1 from both sides to get x is greater than or equal to 0. And on this side, I'm going to add 1 to both sides to get negative x is greater than or equal to 2. Multiplying both sides by negative 1 or you could even just divide both sides by negative 1. Either way, you get the same result. Just x is, sign is switched, less than or equal to negative 2. And what that looks like down here on the graph is this. This is x is greater than or equal to 0. Solid dot on the 0, shading to the right. Solid dot on the negative 2, shading to the left. This is all the numbers on the number line except the ones that are not shaded, which are right here. Write a compound inequality that is represented by the graph. So let's go in the reverse direction. Let's start with the graph and see if we can come up with this compound inequality, the statement business up here. Well, what I'm seeing here is negative 2, and then going to the left, and then open dot on a 4 going to the right. I think it's going to be kind of like it looks like one of these, so that's like an or. So I'm going to have 2 statements. One, x is, looks like, less than negative 2 or equal to negative 2. Or x could be greater than 4. There it is. Here, I'm seeing this. Oh, we have 2 dots and the thumbs are touching, so that we got like one of these statements over here. So that's going to be negative 3 is less than x is less than or equal to, and I want you to figure out what's underneath the red dot. Take care, and I'll see you in class.